Okay, so for your quiz tomorrow, we're going to be reviewing most of the concepts that we've learned for this marking period. So the first thing that you're going to need to know is sort of the difference between these congruence transformations. So what does a translation look like? What does a reflection look like? A rotation. And then this last one here, this is not a congruence transformation. We're actually going to get into this next in the next unit. This dilation, notice it doesn't preserve congruence, right? It doesn't preserve shape and size. So these shapes are different sizes. So therefore, it's different than these other three transformations because it changes the size of the shape. So a dilation is not a congruence transformation, but a rotation, a translation, and a reflection are. So just be able to identify, when it's a reflection happening or a translation or a rotation. Okay, next you're going to look at triangle congruency or just polygon congruency. And so being able to identify congruent parts from a congruency statement. So for example, here I have triangle ABC is congruent to triangle DEF. And so I know that angle A and angle D would be congruent. Use a different color here. I would know angle B and angle E would be congruent. And then I know angle C and angle F would be congruent. Okay, so I've shown angle congruency. Now I can also say that side AB, bear with my writing here. Okay, side AB would be congruent to, from the other one, side DE, because AB are the first two vertices, and then DE here would be the first two vertices, okay? So side AB is congruent to side DE, and then I have two other sides. I could also say, I could say BC is congruent to EF, and then I can also say that CA is congruent to DF. So you can see how I used these triangle names to help me determine which angles and which sides match with each other. Okay, next, you're going to have to identify your angle relationships and determine different angles based on those. So for example, here I have two parallel lines and this transversal C. So what it does is it creates all these relationships. So what's color coded in this diagram are corresponding angles. So these, so 132, 132 here. So the green angles are corresponding angles. And so are, actually I should change that to just the colors. Color coded. They're corresponding angles. So 48 and 48 here, the reds, the yellows, and then the greens. So then we also have other angle relationships I'll kind of mark off here for you. So we also have alternate interior angles, would be these two guys. They're on different sides of the transversal, but on the inside of the parallel line. So those are AIA, alternate interior angles. We also have, let's erase those, alternate exterior angles. So this 132 and this 132. So they're on opposite sides of the transversal and they're on the outside of the parallel lines. So those are alternate exterior angles. Notice those are the same measure. Okay, and then we also have a relationship among the same side angles. So I have same side interior angles. This 132 and this 48 would be same side interior. And notice they're not congruent anymore. They're not equal. They actually sum to 180. So they're supplementary. So those add to 180. And then another color here, we also have alternate exterior, same side exterior angles. So these two, again, are supplementary, not congruent. So same side exterior, same side interior are supplementary. So you can see there. So these relationships are important to know in order to solve for missing side lengths in a diagram as such. Okay, next we have, you're going to need to know your angle, your triangle congruency criteria. So we learned side, 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 angle, side, and angle, side, angle. So if you recall what that it says if we have two sides congruent, say, and the angle in between those two sides also congruent, then we know that those triangles must be congruent by side, angle, side. Okay, and we can also look at what if we have all three sides congruent. So we know this is congruent as well. I'm going to get that those two are congruent, and then look at this one, 3 tick marks. Now we know this triangle must, or these two triangles must be congruent to each other by side, side, side. And then the last possibility I could have is that I have an angle congruent to another angle congruent to another angle, and the side in the middle of those two congruent. And that would prove congruency by angle, side, angle. So tomorrow you can anticipate having some questions about which one of these would prove triangles congruent. And remember, we do have the scenario. So let's say we only have one triangle and there's a line going down it, segment going down it, and I'm trying to prove these two triangles congruent. Don't forget that we have that thing called the reflexive property right here that says it shares, so these two triangles share this side, so it says this side must be the same in both triangles. So you can use that to prove the triangle congruency. And on your practice assessment, you have some questions about this to practice out. All right, next we have triangle inequality theorem. So what this says is two sides of the triangle must add to greater than the third side. So 5 plus 6 is 11, which is greater than 7. 5 plus 7 is 6, which is greater than, 5 plus 7 is 12, which is greater than 6. And then 7 plus 6 is 13, which is greater than 5. So this could possibly be the side lengths for a triangle. We also want to remember that the side across from the greatest, or the angle across from the greatest side is going to be the largest angle. So this one would be greatest angle. And then the angle across from the smallest side is going to be, so this is our 5, is our smallest side. This angle must be the smallest angle. Okay, so if you have a problem where, say the greatest angle was down here, and that was not across from the greatest side, the longest side, then that triangle can't possibly exist. Okay, another theorem to remember, that all of the angles inside of a triangle add to 180 degrees. Okay, so if you know 2 of them, then you can figure out the third one. There's some problems on your practice assessment to practice that. And then this, our exterior angle theorem. This says that if we know these 2 angles inside a triangle, and we're looking for this exterior angle out here, we know that it's just going to be the sum of those 2. So 30 plus 80 will get us 110 degrees out here. Okay, and then don't forget that that's supplementary with this interior angle. So we know that this angle in here is going to be 180 minus 110, or 70. And then you can check that all 3 of these add up to 180. All right, and then the last thing you're going to need to know, So a question like this, each interior angle of a regular polygon equals 60 degrees. How many sides does that polygon have? So here's the formula you want to have on hand to use. You're going to set this. So we're trying to figure out how many sides this polygon has. So that n there is what we're trying to solve for. So you're going to set this equal to, in this case, 60 degrees, because this is the formula that solves for how many degrees are in polygon, or for each angle inside a polygon. So then in order to do this problem, I'm going to multiply both sides by n to eliminate the n in the denominator here. Okay, so I'm going to type the rest of this. So I end up getting over here 60 times n, which gives me 60n equals 180 times n minus 2. So eliminate the n here. All right, and then now I'm going to distribute the 180. So I get 60n equals 180n minus 360, because what I did is I distributed that 180 times n, and then 180 times negative 2 is 360. All right, and then now I'm going to subtract, I'll write this, 180n from both sides. So minus this 180n, because I'm combining my like terms on both sides. This is our solving equations that we practice with the PSAT. So minus 180n, forgive my writing, not too great with the mouse. Okay, so that goes away. So I end up with, so 60 minus 180 is negative 120, n equals negative 360. And then my last step to solve for n, for solving an equation, I'm going to divide both sides by 120, and that's going to get me n equals 3. So what I've discovered here is the answer to this question is a 3-sided polygon, which is actually just a triangle. We'll have each of its angles equal to 60 degrees, and we know that that's an equilateral triangle. So there's a lot of practice problems on your practice assessment, similar to all of these that I went through. It goes over all these topics. So make sure that you do those in preparation for tomorrow.